So yesterday we discussed about Henry Moseley. Henry Moseley. He gave modern periodic law. When did he give modern periodic law? 1913 AD. But periodic table was designed by Mendeleev. Who designed? Mendeleev. D.I. Mendeleev from Russia in 1869 AD. Ritik, where are you looking at? Whiteboard is here. Smartboard is here. So focus this side. And he gave one law. That law is called modern periodic law. What does modern periodic law state? Physical and chemical properties of elements are the periodic functions of their atomic numbers. If you are able to write this one sentence, you will get 1 mark, because such a question can be asked in BSQ. Very short questions. Understood or not? So, I have reminded many times, presence of mind. There must be presence of mind. That means focus on subject matter. What the teacher is saying, what is going on inside the class, and someone is looking outside, sutuk, why? It's very bad. So, and this is periodic table, but this is not the periodic table designed by Moseley. This is long form. This is designed by Bohr and Bury. Okay, I'll read this one. Okay, in today's class, we are going to discuss inert gases, periods, atomic size, groups. So, by tomorrow, we will complete this chapter. Understood or not? Let's complete. By tomorrow, let's try, because this chapter is also taking long time. Are you ready?
Yes, sir.
Yes, sir.
Are you ready to learn?
Yes.
Okay. So what is discussed first set in mind, and later on you express yourself. But now what have we started? Expressing in question answer pattern. Understood or not? And are your guardians taking homework regularly or not? Remind them, and don't forget to take it correctly. Okay? And please do it well. So this is the time to make your best. What is our next heading? What is the next heading? Please read here. Position of different elements in the modern periodic table. We are not discussing about Mendeleev's table. We will discuss about modern periodic table. So, position of hydrogen. Where is hydrogen kept? Where hydrogen is kept in group 1. Hydrogen is kept in group 1. One thing, actually when we see here, in group 1, there are metals. Lithium is metal, sodium is metal, potassium is metal, rubidium is metal, cesium is metal. But in the group of metal, who is kept? Which element is kept? Hydrogen. Why is it kept in group 1? What's the reason? Because hydrogen contains 1 electron in its valence shell. Where? 1 electron in its valence shell. When you talk about lithium, sodium, potassium, rubidium, cesium, francium, their valence shell also contains 1 electron. Hydrogen also contains 1 electron. That's why hydrogen is kept in where? Group 1. Is that okay? Understood? What the teacher is saying, please pay attention here. It is not the matter that repetition goes like that. Okay, now second one is position of metals. What is here? Position of metals. How do you define metals? Please read here. Will you read 2 times? Now here is one thing to remember, lose electrons. Metals always donate, give electrons to others, and they become positively charged. I mean, if I write sodium, sodium becomes positively charged. Magnesium becomes which one? Positively charged. Lithium becomes positively charged. How did it become positively charged? By losing electron. When electron is lost, they become positively charged. But I have written here 1 plus, here 2 plus, here 1 plus. What does it mean? What does it mean? It means it loses 1 electron. It loses 2 electrons. It loses 1 electron. If I write here Al plus plus plus, it loses 3 electrons. How many electrons are there in the valence shell? Those electrons are donated, lost, and positive charge is gained. Okay? So if you look at here in this periodic table, group 1, remember, group 1, group 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Group 1 to group 13, all elements are metals. All elements which belong to 1 to 13, they are metals. And this down one, lanthanides and actinides are also metals. So many metals are there, right?
Yes.
So metals are kept in group 1 to group 13 and lanthanides and actinides. What can metals do? Lose electron and become positively charged. They lose electron and become positively charged. Children, earlier we discussed about this valency. Hydrogen valency 1. Valency 1 means either it gains 1 electron or loses 1 electron. Lithium 1 means there is transfer of how many electron? 1. Boron 3. Nitrogen 3 or 5. Fluorine 1. Sodium, that is the thing. Okay. So now here is something to remember. Alkali metals, alkaline earth metals, transition metals. What is given? Alkali metals. Group 1A metals. All those elements which are present in group 1A, what are they called? Alkali metals. Which are present in group 2, what are they? Alkaline. Where are alkali metals located? Group 1. Alkaline earth metals? Group 2. And next thing, transition metals, where are they located? 3 to 12. Right? 3 to 12. Okay. Some elements from 13 to 15, they also have got metallic properties, but 1 to 12, they all are metals. May you remember, I just said alkali metals. Where are alkali metals? 1A. Alkaline earth metals? Group 2. Group 1, alkali. Group 2, alkaline earth metals. Group 3 to 12, transition metals. You have to mark all these things. Eh? Now children, position of non-metals. Where are non-metals? Non-metals lie in group 14, 15, 16, 17, 18. 14 to 18. They are non-metals. But how do you define non-metals? What are non-metals?
Non-metals are the
Elements which gain electron from other. Yes. They gain electron. It means they have got positive charge or negative charge? Negative charge. Metals, positive charge. Non-metals, negative charge. Alright. Where are they placed in the periodic table? 14, 15, 16, 17, 18. Right? Metalloids. What are the metalloids? Any idea? Metalloids? Metalloids means there are some elements
Which contain
which possess some characteristics of metals, some characteristics of non-metals. They are called metalloids. How to define metalloids? Elements which possess the characteristics of both metals as well as non-metals. They are called metalloids. What are the examples of metalloids? Polonium, boron, silicon, germanium, arsenic, antimony, and tellurium. Once again, let's check here. We have got lovely thing. Playing Sudoku. One game was there, Sudoku. I don't know what they used to play. Right? Yeah, so what is this? Boron, silicon, germanium, arsenic, tellurium, polonium. These, I think, brown color, right? Which is color with brown. These are metalloids. These elements, left hand side all are metals, right hand side all are non-metals. This middle one are metalloids. Metalloids possess the characteristics of both metals and non-metals. How many metalloids are there? 1, 2, 3, 4, 5, 6, 7 only. And out of 118 elements, whose number is maximum? Metals are maximum. Non-metals are a bit less. Metalloids are very less. In metals group, one non-metal is kept. Hey, what is that? Hydrogen. Okay. Children, here is one word. What is given? Position of inert gases. What do you mean by inert gases? Inert means inactive or passive. Inactive or passive gases. There are some gases which are active, like oxygen is active gas, nitrogen is active gas, chlorine, bromine, fluorine, these are active. But there are some gases which are inactive. Where are they kept? They are kept in group 18. What are the examples of those inert gases? Helium, neon, argon, krypton, xenon, radon. They are inactive or passive gases. Why are they passive? Why are they passive? Yeah, they do not take part in chemical reaction. They do not take part in. Why they do not take part in chemical reaction? Actually, they take part in chemical reaction to balance the electron. To balance the electron in valence shell. But their valence shell is already balanced. Their valence shell does not need any more electron to be balanced. That's why they are passive. Okay? They do not take part in chemical reaction. So, while talking about the position of elements, at first what did we discuss? Position of hydrogen. Second one. Next one. Next one. Next one. So, elements are kept in different groups. Accordingly, they are kept. And they have got name also. Group 1 elements, what do you call them? Group 1, alkali metals. Group 1, alkaline. Group 2, alkaline earth metals. What are they? Group 3 to 12, 14 to 18, non-metals. Group 18 only, inert gases, right? And metalloids lie between 13 to 15, right? Okay. Now children, when you look at this periodic table, you can see vertical, actually it is kept in this way, vertical column, horizontal rows. Now once let's check in our what are you going to check here? Periodic table, okay? Then it will be easy. Let's go. Periodic table. Friends, here is the periodic table, right? Yes or no? This periodic table contains this vertical columns. What are they called? Vertical columns. So these are called groups. Vertical columns present in periodic table are called groups. How many groups are there? 18. Already we discussed. Are you paying attention here, master? Pay attention here. Looking at the ground means you don't learn anything. And horizontal rows, see, these are called periods. Horizontal rows are called periods. Vertical columns are called groups. So, okay, what is this? What are these? Groups. What are these? Periods. So, mainly there are groups and periods in periodic table. Vertical columns are called groups. Horizontal rows are called periods. Right? Please come. What is the definition of period? Rows running horizontally across the table. They are periods. And how many periods are there? 7. First one is first period. Up and down is second, third, fourth, fifth, sixth, seventh. And how do you define columns? Sorry, groups. Vertical columns, right? How many are there altogether? 18 groups. How many periods? 7 periods. So, if somebody asks you to differentiate between, what is that? Are you busy with somebody, boy? What is that? Pass it here. What is, which subject is this? Now, health, you have to be busy right now. One walk at a time. We are discussing science, mind is in health. We have to do long toilet and thinking about food. What is this? Long toilet means throw everything. Yes or no? And go in canteen, eat photo. Both things, how can you do together? So you sugam thapa magar. Be careful. And you prayas ji. Your prayas is bad. Name is prayas, but prayas is doing a different thing. Prayas should do prayas in one subject only. Yes or no? Mind is distracted. Okay. Periods. What is the definition? Rows running horizontally across the table are called, what are they called? Periods. Altogether, how many periods are there? 7 periods. And these 7 periods are categorized into 4 types. How many types? What are they? Very short period, long period, very long period. Very short period means there are presence of how many elements? 2. In short period, 8. Long period, 18. Very long period, 32. Okay, 4 type of periods. So 4 periods already I just said. That's great. Now characteristic of period. What is next? Characteristics of periods. What is the first one? Physical and chemical properties. What does it say? Please read together. The physical and chemical properties of the elements within a period gradually change while moving from left to right. When we go from left to right, what will happen? Properties, physical properties and chemical properties changes. Like, it's okay. Here, Hey boy, imagine Tanji with this one now. Buddha Saini. Buddha Saini does the work like Buddha Saini. Pay attention here. So if you talk about this one, first, second, third period. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. When you go from left to right, their physical properties and chemical properties remain same or changes? Changes, slightly changes. Okay. Physical properties means whether solid or liquid or gas. Color also, right? And next one, chemical properties means reactivity with others, right? And now next one is, what is second one? Valence electron. How do you define valence electron? Number of electrons present in the outermost shell. And what is said here? All the elements of a period have the same number of electrons or energy levels but different valence electrons. Valence electron remains same or different? Valence electron will be same or different while going from left to right? What do you think? Again, let's see here. Like, valence electrons will remain same or different? Different. For if you talk about sodium, there is one valence electron. Magnesium, 2. Aluminium, 3. Silicon. Then, when you go from left to right, valence electron changes. Does not remain same. Next point. What is third one? Valency. So, here is given the definition of valency, very simple definition. Please read. Combining capacity of its atom. And valency remains same or changes. See here. What is the valency of sodium? Magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Valency remains same or changes? Changes. At first increases. Yes or no? At first? And again decreases. Increasing, decreasing. That is valency matter, right? How many characteristics have we discussed? 3. What are they? Physical and chemical properties remain same or changes? Changes. Valence electron? Changes. Valency? Uri Baba, 3 things are changing, right? What is the first point? Atomic size. Size of atom. What do you think? Atomic size increases or decreases? Here is given the diameter. Check here. Atomic size? When we go from left to right, there will be halwa type. It means in between sodium. Okay, now we can see it. Here is sodium. Here is argon. Right? So in third period, which element has the largest atomic size? Sodium has largest atomic size or argon? You said atomic size decreases. Sodium has largest atomic size. Argon has. In between sodium and magnesium, which atom is bigger? Sodium is bigger. Magnesium is smaller. Between aluminium and phosphorus, which atom is bigger? Aluminium bigger, phosphorus smaller. When you go from left to right, atomic size decreases. Mark these things. That's why I just said there must be presence of mind. Means focus on it. I said not to carry anything. Master Purasani again started holding the ball pen. Make the agony straight, boy. Relax. Atomic size decreases. Metallic character and electropositive character. Metallic character means metal's character. So metal's character increases or decreases? What do you think? Metal's character decreases. and electropositive character also decreases. I mean, so it is more metallic than this one, right? So metallic character decreases, electropositive character also decreases. Okay, electropositive character means how fast it loses electron and become positively charged. Electropositive character means how fast it loses electron and becomes positively charged. For example, here is sodium myalu. Which element is this? Another magnesium myalu. Here is one electron in outermost orbit, right? Magnesium, how many are there? 2. Which can lose electron faster? Sodium or magnesium? To lose one electron is easy, no? To lose 2 electron, it is easy or difficult? You have to solve 2 partners. Say, partner, do you want to get my electron? If only one is to take one, finish, right? So, it becomes positively charged faster, Na plus. And after losing 2 electrons, then it becomes positively charged. What is that? Mg plus plus. So, metallic character decreases, electropositive character also decreases. Right? How many have we discussed? What is the first one? Number second. Third one. Fourth one. Fifth one. Now we'll discuss sixth one. What is sixth one? Electronegativity. What is electronegativity? Read 2 times. Electropositivity. Remember first. Electropositivity means tendency of losing electron and being positively charged. Electronegativity means tendency of gaining electron and become negatively charged. Here, electronegativity increases or decreases? Increases. When you go from left to right, these elements can gain electron faster. Sodium, lithium, does it gain or lose? Loses. Beryllium loses. Boron loses. Carbon sometimes. Now it has to gain also. But nitrogen, oxygen, fluorine, they gain faster than others. So, electropositivity decreases, electronegativity increases. Means as we go from left to right, tendency to gain electron increases. What is the last number? Reactivity. Reactivity means taking part in chemical reaction. What is mentioned about reactivity? Just check here. Read. Udan? Miss, did you finish? I am not writing this one. What is this? Lithium. This is second period. Which period is this? Second period. And this period of school is also second period. This is periodic table second period, and we are discussing in school second period, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So if I write like this, it will be easy for you. About chemical reactivity, what do you write? At the beginning, chemical reactivity decreases. Chemical reactivity decreases from lithium to boron and increases from carbon to fluorine. These are metals. Lithium, beryllium, boron. What are they? Metals. Carbon, nitrogen, oxygen, fluorine. They are non-metals. And neon is inert. Inert means it is passive. So while going from left to right, at first chemical reactivity decreases, then again increases up to group 17, and group 18 is passive. Last element is passive. So we can say at first chemical reactivity decreases, later on chemical reactivity increases. That is the characteristics, right? Let's do once recap and then I will give you some tags. So what we discussed today? Position of different elements in periodic table. What are they? Position of hydrogen, the metals, position of non-metals, metalloids, position of inert gases, and then consider periods and groups. Periods, vertical columns are groups, horizontal rows are periods. How many periods are there? 7, and they are categorized into 4 types. What are they? Very short period, long period, very long period. And what are the different characteristics of period? Physical and chemical properties, valence electron, valency, atomic size, metallic character, and electronegativity and reactivity. And in tomorrow's class, we are going to discuss groups, their characteristics, and other things. Is that okay? All right. So now be ready to copy the questions. Take out your rough copy.